Okay, so let's get on to example number 1. So it says evaluate the inverse trigonometric functions without a calculator. Now, what does it mean to really evaluate? And I think that's one of the critical points that we need to kind of make here. You know, we're trying to find the value of this inverse trigonometric function, but to really understand the value of the inverse trigonometric functions, we got to remember, like, what is the value of a trigonometric function? Like, why do we use the trigonometric values? And again, that kind of goes back to our like triangle days. So just kind of a real, quick reclaps here. When I had a triangle and, let's say this is like 30 degrees and this was like, I don't know, 5 and this would have been 10. I say the sine of 30 degrees is equal to 5 over 10, right? So we're always taking the sine of an angle. That was an important thing. We're taking the sine of an angle. So in this case, if we wanted to rewrite this in the inverse operation form, what we'd basically have here is like the sine inverse of 5 over 10. Now that's going to equal our angle. So what we're doing here is we're looking for the angle. And, we're not writing an equation here, but a lot of times I like to think of, what is this value? This is some angle, right? And, you can use a question mark, you can use theta, but basically what we're trying to ask ourselves is the sine of what angle is equal to 1/2. Now, from our knowledge of the unit circle, we know that there are actually 2 points where the sine is equal to 1/2. So, if we just go ahead and sketch the angle for 1/2 here, we know that the angle at pi over 6 is the coordinate point square root of 3 over 2, comma, 1/2. And then we also know that the angle 5 pi over 6, that has the coordinate point of negative square root of 3 over 2, comma, 1/2. However, the sine, the y coordinate, is both 1/2. So, it kind of like begs us our question, like, then do we just write like both answers? Do we write, well, then that equals 5 pi over 6 and, pi over 6. But again, that doesn't make sense, right? This is an inverse function. Inverse functions, you plug something in and you're going to get something out. It's not a function to have something, to have an input and then have 2 different outputs, right? And again, so that's where it comes down to our, restrictions. And you can look at the graph. It's kind of nice. Like we look at the sine graph. The sine graph is restricted between negative pi halves and pi halves. If you try to see like where is the angle 5 pi over 6, well, that's almost to pi, right? 5 pi over 6 is almost to 6 pi over 6. So that's like way over there. That's not within the restriction. But pi over 6 is less than pi halves. That is within the restriction. Or the other way that I like to look at it is look at the restrictions here. So if you kind of look at this, model here, here's pi over 6 right there. That falls within the restrictions of sine. It's in the first quadrant, right? However, 5 pi over 6 is outside of the restriction, so therefore it doesn't work. So our only answer, because it is an inverse function, it is a function, we're only going to have one answer, which is just equal to pi over 6. All right. For the next one, cosine, a negative square root of 3 over 2. And again, we kind of look at this. Let's just look at our 2 angles here. Now, this one is, we got to know our unit circle. And again, we're looking for an angle, right? So we're basically saying, the cosine of what angle is equal to the negative square root of 3 over 2. And again, by the unit circle, we know that square root of 3 over 2, that is the same thing as the pi over 6 as we did over here, right? But that is a positive 3 over 2, comma, 1/2. That's the positive version of our x-coordinate. We need to find the negative version. And so the negative version is in the second as well as in the third quadrant. So that coordinate point is negative square root of 3 over 2, comma, 1/2. And this point is negative square root of 3 over 2, comma, 1/2. So what are these 2 angles, right? And these 2 angles, obviously, if this is pi over 6, you can see that these all have the same reference angle. They're all pi over 6 away from the x-axis, which is 6 pi over 6. So if we're pi over 6 short away from 6 pi over 6, that means we're at 5 pi over 6. And if we are pi over 6 pi over 6, then that means that angle is 7 pi over 6. So again, though, we can't have 2 answers. Like, which is our answer? Is it, 5 pi over 6 or 7 pi over 6? And again, that's where we fall within the restrictions. The cosine inverse function has a restricted range, has a is from the restricted cosine function between 0 and 2 pi. So the only angle that we can use is between 0 and pi. So the only angle that fits within that is 5 pi over 6. All right, so the tangent of 0. Now, again, remember tangent. We need to look at the y coordinates, like when is tangent going to be 0? So in this case, a lot of times I like to look at the unit circle, but without the coordinate points, but just looking at the intercepts. So remember, this is 1, 0. This is 0, 1. This point is -1, 0. And this point is 0, -1. All right, so when is tangent going to be 0? Well, the only angles tangent is 0 is, remember, tangent is the y coordinate over the x coordinate, right? So y over x is equal to 0 for the angle 0, basically not moving anywhere. And then also between the angle of 0 over -1, which is the angle pi. But the problem is, again, if you look at the restrictions of tangent, we can only use angles that are between -pi halves and pi halves. So that's going to be the angle 0. All right, so the arcsine of, now the other thing, remember, we can interchangeably use arcsine instead of tangent, or inverse. So arcsine, again, basically asking us the same question: what is the sine of what angle is going to equal -2 over 2? And so we know that sine is going to be negative at these two angles, right? And we know that they have to have the same reference angle as pi over 4. Because when I think of my unit circle, I guess we'll just kind of do this over here. Let's just do a quick little unit circle so we can reference this. Because a lot of people may not have the unit circle memorized, which hopefully by the time you take a test or a quiz, you will, because it's very, very helpful to be able to reference this. I'll zoom in there. And that's for pi over 4, and this, let's just redo this. That looks bad. Let's do a nice big one. Or at least as big as I can. So I'll do pi over 6, pi over 4, pi over 3. So again, we have pi over 6. From here to here is pi over 3. And then from there, there is pi over 4. So just remember, again, these points here. This is going to be 1/2, comma, square root of 3 over 2. This point is square root of 2 over 2, comma, square root of 2 over 2. And this coordinate point is square root of 3 over 2, comma, 1/2. Okay? So yeah, so you can see that, obviously this angle is, the reference angle of pi over 4 that I'd like. How did I mix those up? That's embarrassing. Jeez. That is pi over 4, and that's pi over 3. Okay. So anyways, you can see pi over, the y coordinate, right? Because sine of an angle of the y coordinate is square root of 2 of 2, but therefore it has to be it has to be negative, so it has to be in the third and the fourth quadrant. Well, again, based on my restrictions of sine, you can see that the angle cannot be in the third quadrant. The only angle that's going to work is in the fourth quadrant. But here's where the issue comes in. So students are like, all right, it has to be within the first and the fourth quadrant, right? So the angle that works here is this angle. So it's not 5 pi over 4, but it's going to be 7 pi over 4. But the issue is, that's why I kind of use the word of like a cage. You have to remain within the restriction. You can't go outside the restriction and then come back in. You can't go outside the cage and come back in within the cage. You have to be contained. So we have to understand the angle. We know this is the terminal side. We know this is the point that we need. This point is square root of 2 over 2, comma, negative square root of 2 over 2. It works. Our y coordinate is negative square root of 2 over 2, just like this one, but that one's not within the restriction. This one's within the restriction, but we got to figure out what angle makes this work without going outside of the restriction. And our answer is just the negative version. Instead of going up pi over 4, we can go down pi over 4. So the answer is negative pi over 4. Okay, so that is at least my introduction way explaining these. Now for the remaining problems, I'm going to just kind of speak a little bit quicker. Not speak, well, I always talk fast, but I will kind of move through this a little bit faster as far as not without the explanation, so we can make sure we get through these, because obviously, don't want to explain the same thing over and over again. We basically have now covered what you need to know. Now we just need to do it. So the arc cosine of 1/2, obviously we're looking for angles that are in the first and the fourth quadrant, or first and the second quadrant. If cosine is in the second quadrant, it's negative. So therefore this has to be the angle in the first quadrant. The only angle, the cosine of the angle that gives me 1/2 is going to be pi over 3. Right. And if you look at the angle pi over 3, you can see the cosine is 1/2. Arctangent of 1. So again, we're looking for the angle when we take the tangent of it is going to give us 1. Now this one I do want to look at because, it's important to understand when we look over here, when I first did the tangent, I was looking for when tangent is equal to 0. Well, there's 2 examples. Well, if I look at this again, is there any example where tangents equal 1? Whenever there's a, 0 over 1 or 1 over 0, it doesn't matter. I'm never going to get 1 here. So now I look at these angles and I can see that the only angle that is going to produce tangent being 1 is pi over 4. And again, since that's positive, tangent is positive in the first and the third quadrant. However, the third quadrant is not within the restriction of tangent, so it has to be the angle in the first quadrant, which is just pi over 4. Sine inverse of -1. That's easy to kind of look over here. You can see that when is the y-coordinate -1? Down here, right? But again, just be careful. Don't go down to here, because that is correct. The side coordinate is -1. But that is wrong, because now you're going outside of our constraint. We have to remain within the constraint. So that means the constraint is going to be this direction. So basically, how do we go? What is the angle down in that way? And that's going to be a negative pi halves. Don't know where that line came from, so hopefully let's get through this one. The next one, cosine inverse of 1. So again, we're looking at the graph and saying when is cosine, for what angle when the x-coordinate is equal to 1. And you can obviously see then that is going to be our angle 0, right? Because that's the only time the x-coordinate is equal to 1. What is that angle? 0. We don't want to say 2 pi, because obviously if we go to 2 pi, we're going to go outside of our restriction. All right, next one, sine inverse of square root of 3 over 2. So again, we're looking at the sine of what angle gives me the square root of 3 over 2. Well, again, that's just going to be pi over 3. This one, the cosine inverse of what angle gives me, cosine of what angle is going to give me negative square root of 2 over 2. Again, it has to be, that angle restriction has to be within the first and the second quadrant. Obviously, since it's negative, I know it's going to be an angle in the second quadrant. So I look at, well, what angle has cosine equal to square root of 2 over 2? Well, that's pi over 4, but that's in the first quadrant. So if it was negative, if it's in the second quadrant, well, then that's going to be 3 pi over 4. Because 3 pi over 4 has the same coordinate point as pi over 4 in the first quadrant, but 3 pi over 4 is in the second quadrant. All right, so the tangent ones, stink if you don't have enough practice. But if you've done a lot of these practice, you're going to get these rather quickly. So remember our coordinate points. Tangent is y over x. So we have 2 coordinate points that we need to kind of discuss. We have this coordinate point, 1/2, comma, square root of 3 over 2. That is for pi thirds. And then we also have the other coordinate point, square root of 3 over 2, comma, 1/2. Now, when you find the tangent of these angles, you're basically, again, doing the y-coordinate over the x-coordinate. And if you've done enough problems simplifying these, you will realize, oh, that is square root of 3. When you go ahead and simplify this one, you get 1/2 over square root of 3 over 2. You simplify this and you say, oh yeah, that one simplifies to square root of 3 over 3. So when you do enough practice of these, you start to see the relationships here. And again, this is for when theta equals pi over 3. This is for when theta equals pi over 6. So I like to kind of keep those as, you can use those now to do these problems. And if I look at this, so it's basically like the tangent of what angle is equal to, negative square root of 3 over 3. Well, it's not as easy as like identifying the x and y, coordinates, because tangent is the ratio. But I look at this and I see, oh, square root of 3 over 3, that came from the y over the x of this coordinate point, which is theta pi over 6. But I don't want to write just pi over 6, because it's negative. And remember, tangent is only negative in the second and the fourth quadrant, and only the fourth quadrant is within our restriction. So we can't go in the second quadrant. We have to find the angle in the fourth quadrant. That's going to give us a at pi over 6. And again, there's two angles. So here's our angle. And again, we can't go outside and come back in of our restriction. What we're going to have to do is go through the negative version, which is a negative pi over 6. So that'd be negative pi over 6. Square root of 3 that's going to be the positive version of square root of 3 comes from square root of 3 over 2 divided by 1/2, which is that angle, which is pi over 3. That's positive. We know in the first quadrant tangent is positive, so therefore we can just say that one's easy as pi over 3. So a couple things just to kind of recap here real quick. Be very careful when you have negative angles, right? Because when you have negative angles, or when you have negative values, when you have negative values, that means that your function is going to be obviously negative. And there's only one quadrant where your angle is going to, for each of these, is negative. Tangent is only negative in the fourth quadrant. Sine is only negative in the fourth quadrant. And cosine is only going to be negative in the second quadrant. So when you have negative values, you're only going to be looking for an angle in those quadrants. Also, look for when your value is positive, because when your value is positive, notice how tangent, sine, and cosine are always positive in the first quadrant. So therefore, you're just basically looking for your value in the first quadrant, which is typically nice for a lot of students, to be able to just focus on the right first quadrant. And then the other just major mistake that I see with a lot of students do is, they have the right angle or they have the right terminal side, but they try to use angles that go outside with the restriction and come back in. Just make sure you keep your angle within the restriction, because, when you're trying to identify the sine inverse of 1/2, what does that equal? Well, that equals an angle, right? Just like the sine of an angle is equal to a given ratio or a given value. And again, that comes from this idea of what we first learned when we did triangles. So now what we're going to do is kind of look at the composition of these functions and kind of see how that is going to relate to what we just did.